finally, the last part, part 4. We are going to solve. That means we're looking for the x-intercepts or the roots. Okay, before we solve, you know it always has to be set equal to 0, so I'm going to subtract 12 from both sides. 6x squared minus 14x minus 12 equals 0. Now I may begin to solve. First question that will not change. Can I make it simpler? Is there a number that goes into 6, 14, and 12? Yes. I am going to take out a 2. That would be the greatest common factor, leaving me with 3x squared minus 7x minus 6 equals 0. Okay. Didn't bring it all the way down to where a is 1 and I could do the x, but they're at least smaller numbers. Because a is not 1, I need to do the ACB table. I need factors of 3 and negative 6, so negative 18, that give me a sum of negative 7. Well, I will just list them out. I could have 1 and negative 18 gives me a sum of negative 17. 2 and negative 9 get me a sum, of negative 7. I said 9 and wrote it down at the same time. Well, there they are. Perfect. I will now have my a term of 3x squared. We have the b and the c. I have negative 6. We broke the b into plus 2x minus 9x. Now, please take a moment and look at the a, b, and c's. I used this trinomial. Do not forget about the 2. We need to drop it down. It is still part of our final solution, but I did not go back to this beginning trinomial. I used these a's and b's and c's to make my table. Therefore, when I put it in this, I need to use the simplified version. 3 steps. Step 1, grouping. So I'll group this and that. Step 2, greatest common factor. For a minute, I'm just going to ignore that. My greatest common factor is simply x, leaving me with 3x plus 2. Notice our signs are completely opposite, so I need to pull out a negative number. The greatest common factor is 3, leaving me with 3x plus 2. Well, that is super exciting because I have identicals. So highlighter time, highlight things that are the same. That's the goal. Combine my greatest common factors. 1 set of identical. And now I will drop down that 2 again. Do not forget about the 2 we've been factoring out. So in the most simplest form, 2 times x minus 3 times 3x plus 2. If we forget to take out the 2, we eventually will. Remember, when solving, you can never have a greatest common factor greater than 1 left in the parentheses. Next problem. I need to bring this to that side, so I'm going to minus 15x, minus 15x. We need to have it set equal to 0. So I have 21x squared. Ooh, those are like terms. I can combine them to 21x. Okay, well, a few things I noticed. We don't even have a trinomial here. We have a binomial. But my question is going to remain the same. Can I make it simpler? Can I factor something out? Well, sure, I can take out 21x. That would leave me with x minus 1. Oh, wait a minute. Silly me. I got two things going on. I forgot we were solving. I was so excited to show you to remember that we take out a 2. So I'm going to go back to this one. I apologize. I forgot we were solving. Remember, when we're solving, we're looking for the x-intercept. So I'm going to take all of the factors, set them equal to 0. Will 2 ever equal 0? No. That makes sense. We started with an x squared, so I knew I would really only have 2 solutions. I would subtract 2 from both sides, divide by 3. My roots are 3 and negative 2/3. My apologies for not going back and solving originally. Back to this one though. I will take each factor, set it equal to 0. X would equal 0, and then x will equal 1. I knew I would have 2 answers. My original equation had an x squared. The degree is 2. That means the x-intercepts are at 0 and positive 1. Okay. Now, what is that first question you're hopefully asking yourself? Can we make it simpler? Yes, I can take out a 5, leaving me with x squared minus 9x plus 20 equals 0. Woohoo! We have a few choices here. Notice the a term is a 1, so we can go back to things we were doing a day or two ago. I need to find numbers that add to negative 9, but multiply to a positive 20. Well, negative 5, negative 4, add to negative 9, multiply to positive 20. Not forgetting about the 5 we factored out originally, I would have 5 times x minus 5 and x minus 4. Setting each factor equal to 0. We know that will never happen. X will be 5 as a x-intercept. And x could be 4 as an x-intercept. But what happens if we just become ACB chart maniacs? Will this still work? Well, my A is a 1. My C is 20, so I would need factors of positive 20 that have a sum of negative 9. So we could have negative 1 and negative 20 to get negative 21. Negative 2 and negative 10 get me negative 12. We're getting closer. 3 does not go in there. We could have negative 4 and negative 5. Ooh, there it is. I would then have x squared minus 4x minus 5x plus 20 using the numbers I used to create the ACB table. We would group. I'm going to pull out my greatest common factor. Oh, I need the signs to be opposite, so I'm going to pull out a negative 5. Whoa, where's the highlighter? Even though I don't write the 3 steps down, I am still super excited about this. Put together the greatest common factors. One set of identical, not forgetting about the 5 we factored out in the beginning. We would end with the same thing. If you forget about this because it seems like so long ago, the ACB chart will also work. And then we would continue to solve and get the same answers. This next one, I would like you to pause the video. I would like you to set it equal to 0, please. My apologies. And solve it for me, please. Pause the video. Thank you for pausing. Can I make it simpler? I don't think so. Okay. I feel like we've done this one before. Okay, my apologies. Once I realized what we had going on here, I needed to change the math problem, not knowing that I had just given you this one not too long ago. So I know on your document you will already have 12x squared plus 38x plus 30 equals 0. Thank you for being gracious with me. Sometimes you know I have a few typos. Okay, still the same question. Can we make it simpler? Yes, a 2 can come out, leaving me with 6x squared plus 19x plus 15 still equals 0. Okay, this will be interesting. Let's see what we get when we bust out our ACB chart. I need to do 6 times 15, which is 90. Yikes. That add to 19. Oh, I think we can handle this one. We can do 1 and 45, 1 and 90, 2 and 45, 3 and 30. Let's see, 4 does not go in there. 5 goes in there. 5 goes in there 18 times. We're getting closer. 6 would go in there. We just saw that 15 times. 7 doesn't go in there. 8 doesn't go in there. 9 times 10 will get me a sum of 19. So I'm going to use my 6x squared as my A term, plus 9x, plus 10x, plus 15. In the back of my head, though, I have not forgotten about that 2. I'm going to do some grouping. Greatest common factor is 3x, leaving me with 2x plus 3. Greatest common factor here is 5, 2x plus 3. Yoo-hoo! We have identicals. Combining my greatest common factor, one set of identical, and now I will bring it down the 2 we factored out a while ago. I did ask you to solve, so 2 equals 0. Never. 3x plus 5 equals 0. Subtract 5 from both sides. Divide by 3. 2x plus 3 equals 0. Subtract 3 from both sides. Divide by 2. Thanks for your patience on that one. My apologies.